and I'm very pleased to be your host today on this webinar on solarizing existing pumps. So we have already a good number of participants logged on. I would assume that in the next couple of minutes we will have more participants. I'm going to start slowly so that everyone who's not on can get the most important content of this presentation nevertheless. You're all on mute, by the way, so don't worry if you talk and you don't hear your voice displayed. That's per design. If you have a large number of people on the same call, it's better if just one talks and the other listens. There is a really nice and functional question function. So on the right side, to your right, typically, you would have your dashboard for GoToWebinar. There is a section called questions, and you can hit that and you can type in all the questions that you have during the presentation. And I can pick up on them either during the presentation, or if they are slightly off topic, then we'll do a Q&A at the end to make sure that all questions are actually answered. So I'll give it another, say, a minute or two. I can see literally second by second more people are logging in. So I give this a little bit more time to avoid that people will miss the beginning of the presentation. Just a minute or two. Good chance to get you another cup of coffee. Hello again. In case you wonder whether your audio was on because you didn't hear anyone talking, yes, your audio is on, but we're just waiting for a few more participants to sign on. So I would say another 1 or 2 minutes, and then we are going to start. All right, so we are now almost complete. So once again, very warm welcome from my side to this webinar on solarization. For those of you who have just logged on, my name is Kai, and I'm looking after our partners in English-speaking Africa. So today this is using a software called GoToWebinar. You are on it already. You're all muted. And so you cannot just, if you have a question, you cannot just ask the question, but what you can do is you can type it. So on your dashboard, when you go to webinar dashboard, but on my side, it's on the right of my screen, you can type in questions, and I'll either answer these questions as we go through presentation, and actually we'll have a Q&A when we're done. This webinar is part of a series of webinars. Last week we actually had one on smart taps and another one on PS2 100, and this week earlier we had one on the new HR pump ends, and this one is well, as I said, this one is on solarizing existing solar pumps. We're going to have more webinars, so stay tuned, and also please feel free to share ideas on content that you would like to see in the future. Right, so solarization sounds like an obvious thing to do, and in fact I would say that it's probably the most obvious application for solar water pumping. And why is that? Well, frankly, solar water pumping is just better. Everybody knows that. Meanwhile, there are no running costs. There is no need for grid or diesel, and solar power has even reached grid parity in most countries. So, in other words, that means there is no cheaper way to pump water than using solar. And the fact that PV modules have become a lot more affordable in the last, say, 5 to 10 years means that it's also going to be more applicable to more applications. And obviously, most applications out there will already have a pump. So solar pumping is not anymore just something for sort of getting the last mile, extending the network to far-flung places. But solar pumping is meanwhile happening literally everywhere, in built-up areas, in suburban areas, wherever people, animals, crops need water, solar pumps are a good solution. And as I said before, also typically the cheapest solution on the long run, after the initial investment has been amortized by not having to spend money on diesel or on grid power. So it's a booming market, and we can all expect it's going to boom for any length of time to come. As I mentioned, since this is now getting into diesel and grid pump territory, there will be a majority of cases where your customer either has an existing pump or at least before had a pump and now looks at solarizing this pump or replacing it with a solar pump. So obviously we need to ask ourselves, first, can we? So is it possible to solarize an existing pump? And secondly, should we? So is it a logical thing to do? Do we actually save money? And let's be honest, that's the first thing that the customer implies to you when he comes to you and says, look, I have a pump, just give me solar, I don't need your pump, just give me some solar and we're going to drive it. So he implies that that solarization exercise would be the cheaper option than if you went and installed him a complete pump. So those two questions will be actually the main content of this presentation. So can we solarize and should we solarize? In order to keep this really practical, we look at a real example together. And this is a village in Wajir, Kenya. So again, this is data that I didn't make up, but this is actually a recent case. The static head here, coming from the customer, of course, is 56 meters. So that's the water level to the top of the tank. They have a water demand of 20 cubic meters a day, and the existing pump has a 4 kilowatt power rating. So how do you go about this when a customer drops something like this onto your desk? Well, first thing you do is start up your compass. So all of us who are now on this webinar and who have compass, now is a good time for you to go to your compass, start it up and get ready, because we will treat this as a normal solar pumping inquiry. Yeah, the job is not solarize the existing pump. The job is find the most cost-efficient solution to get this customer fixed with 20 cubic meters per day on solar. So while you're starting up your compass, let's do the rule of thumb sizing. So when I say rule of thumb sizing, then that's what many solar vendors, many inverter vendors, some of the solar pumping companies or solar pumping vendors apply. This is a very rough and ready sizing that I think probably comes from the 80s. So from the times before we had software to size things. You know that you have now all access to Compass, so you're probably not using this. But for those of the competitors maybe, or those of us in the marketplace who do not have Compass, that is the way they normally do it. And I'm not going into any details why this is right or wrong. Just it's not state of the art, but this is the way many people think. And this is also the way maybe a hobbyist or someone who tries to do everything himself would approach this, and then start buying products off of Alibaba, for example. So what this person would do, he would take, or she would take the motor power and applies like a PV power factor. More often than not, people use 1.5. So for a 4 kilowatt motor, people would think, a 6 kilowatt PV generator is probably what would get me going. So for the sake of the argument, I'm now calculating this with 275 watt peak modules, just because they are quite common. That means you need some 22 modules to get to your 6 kilowatt. Next thing they would do is you would adjust the number of modules in a string for your voltage range. So in this example, it's 500 to 700 volts DC, not OC, but DC. So at VMP, that would mean, at a VMP of 32 volts, that would mean about a maximum of 21 per string. So 22 we can't do, so we'll stay with 21, which is just below 6 kilowatt. There you go, that's it. That's the rule of thumb sizing, so simple as that. And obviously, so incorrect that also is. So the question is actually answered now, at least the first one. You can technically solarize your existing pump because there's PV modules and there's inverters that can probably do the job. You can hopefully see the 2 stars next to my yes. This means that, of course, the story doesn't end here. It actually starts here. And we're going to look at some of the technical and commercial aspects around this solution later in the presentation. Let's actually switch to Compass. So I hope you've had a chance to go to Compass. I will now switch my screen to the Compass view. I hope you can now see my Compass. I will give this a short second for everyone to be on the same slide. So that looks promising. I think almost all of us now see the Compass screen. Obviously, this is a submersible pump application. So we would hit here submersible. It would open our context window. We select our location. I already did this sizing before, so Kenya is pre-selected, Wajir is pre-selected. Obviously, you can select here another location. You put in your total dynamic head. We said 56 meters, and we want 20 cubic meters per day on average. So I hit here on calculate, and Compass is now calculating all sorts of combinations between PV modules and pumps to get the job done. This is our standard view. If you're familiar with Compass, you will initially or instantly recognize this. So what you have is it selects for your pump. It's a PS2 1800 14H with 1100 watt peak, so only 4 modules. If you're not very familiar with solar pumps, that may look very surprising right here, because you remember 6 kilowatt was required for the existing pump. So there is a big difference. Let us go back now to our presentation to compare some prices, shall we? So our result is an 1800 pump, so that's about 1800 watt on the pump and 1100 watt peak to drive the pump and to give us our 20 cubes. Now, if we now look at the price comparison, of course, prices have also always to be taken with a pinch of salt. The prices I'm sharing here are US dollars, yeah, but at this current time and age, it could also be euros. So let's take this would be US dollars, and I'm using list prices for average list prices for solar pump and controller, and I'm using $1 per watt peak installed, so including racking and cables for the PV. Yeah, do your own cost comparison if your prices are slightly different. I think these are more or less realistic prices that an end customer would see in the majority of countries. So on the left side, we have a list of all the cost items for our solarization exercise. So we leave the old pump in, obviously no cost. A controller for this power class typically costs 1,000 plus minus. PV, I mentioned, is then 6,000. Installation, many countries is very cheap. So this is assuming a country which could be in Africa or which could be in South America, relatively low labor costs. So you end up with a total of $8,000 for this project. On the solar pump side, so the pump and pump system, as we call it, so controller and pump together, cost you maybe about $3,000 as an end customer. Your PV is 1,100. Installation is the same, honestly. So the solarization exercise, you may argue, doesn't need to install the pump. But if you've ever installed a pump of this power class, you'll know that this is not a day filling exercise. So the total here ends then at 5,100, which is actually a very simple decision to take. It is not a good idea, right? In this case, solarization is definitely and very simply not a good idea, because you are, as the customer, as the end customer, you're not saving money, but you're actually paying on top for keeping your old pump. Depending on how much experience you have with such inquiries from customers, you may think this is a very realistic or rather very unrealistic example. And don't worry, we're going to do a second example, but take it from me, this is actually the norm. So, and the reason why this is normal, the fact that your solar pump has a significantly different power than your AC pump existent, is that simply there are differences in sizing a pump with AC in mind or sizing a pump with solar in mind. With AC, more often than not, you would buy the biggest pump you can afford, which matches more or less your motor, your yield of your borehole. And then you run it however long you need to take to fill your tank or to water your crops. And the only occasion really when this does not hold true is when by chance you are operating your existing pumps over the normal daytime hours. So sunny, let's assume a sunny place somewhere in the world, that would be daylight hours, maybe 10, 12. Operational hours for the pump maybe 6 to 8. So if you're running your existing pump in a time window of 6 to 8 hours, it's theoretically possible to leave the old pump in and solarize it. Yeah, more often than not, I would say easily 80% of cases it does not match, and then it's just a bad idea to solarize it, because either, like in this case, you are wasting money, or if you are having the other case, which is the existing pump is too small, then you're just not getting the job done. All right, so let's look at a second example now, assuming that maybe 10-20% of cases where by chance you have a match between the operational hours and of your AC pump and the daylight or the operational hours of your solar pump. Let's look at that. So next example is an irrigation scheme near Wa in Ghana. So again, this is an actual example, an actual project. The static head here is 83 meters, and that includes already some 25-27 meters for the drip. The water demand here is 90 cubes a day from November to March, because that's the irrigation season up there, and the installed pump is at 5.5 kilowatt. Our compass exercise would give us a PSK27 12-15 with some 10.5 kilowatt of PV. Again, our rule of thumb sizing says take the motor power, multiply it by 1.5, and you come up with 8.25 kilowatt. That doesn't work because that doesn't give us the right voltage for our inverter. So once you did the maximum 21 per string, you realize that's going to be too big. So you're using 19, which is the minimum, and corresponds more closely to the 500 volt DC minimum input, gives you some 10.45, so the same, right? And here, obviously, the economics look significantly different. So here, if you are solarizing a pump with the same operational hours as a solar pump, more or less, you leave the old pump in, you put a controller, you put your PV, that's the same for both designs. Installation, honestly, will be very similar. Yeah, you may argue not really because you don't have to lift the pump. Well, we discussed this. A little spoiler, you will probably still have to pull your pump. So that's why I put this on the same price level. In the end, you end up with $1,300, $450 for the solarization job and $19,100 for the solar pump job. So that is obviously a really, really significant difference. So now we are at the interesting point of this process, of this thought process. Now we're going to look at, is this not an obvious choice now? Well, it sort of looks like an obvious choice. So you could now maybe consider going for it. Something, of course, to keep in mind now is all the what ifs. And one of the what ifs is certainly, what if you have to replace your pump in, you name it, 6 months, 12 months down the road? In this case, your new pump would cost, if you take the same quality level as for a solar pump, would cost you, say, $3,500. The installation comes on top. Obviously, you have to mobilize another team. You have to probably get a crane, depending on your riser pipes. You have to buy the fuel. You have to pay the stuff. And then you come to a new total, which is very similar to the solar pump total. So I think this is getting more closer now. So this is maybe some food for thought. There are, and now I'm coming here to our start. Yes, there are some more aspects around this. Obviously, the age of the pump is the number one. Yeah, typically AC pumps in rural areas or in not perfect conditions, they live, say, between 3 and 7 years. So let's work on an average of 5 years. So if your customer comes to you with a pump which has already 3 or 4 years, then I think it would be a good idea to tell the customer, look, I can now sell you this solarization solution, but you would have to anyways spend a good number of dollars on your pump replacement in a year or two. So why don't you just get it done now and in one go? Second question to ask yourself, this is not something you can ask your customer, is your pump suitable for variable speed? Yeah, so solar operation means you have variable speed throughout the day, and you have very frequent start stops, particularly in dusk and dawn hours. And most pumps out there are not designed for variable speed. Most pumps out there are designed for 50 hertz or 60 hertz constant speed, and that's that. So you may breach, or you certainly breach your warranty, but more importantly, you can simply very quickly damage your pump. And we're going to look at why that damages your pump later. Thirdly, and I indicated that before, thirdly, can a dry run indication be used with the controller? More often than not, the answer would be no. Many of the AC pumps which have been driven with grid or diesel will have an anode type of configuration where you have a little poti on the top, which sets the switch point for when the pump needs to stop in case the water runs dry. Now that doesn't work with any of the inverters on the market today, so you would have to pull the pump to replace or to fit some form of dry run protection, which means then you have to pay for the mobilization of your rig, and that of course increases the cost and makes it less attractive to actually leave the old pump in, and also it makes it more expensive to solarize it. Fourthly, and certainly not lastly, what about your pipes and tank? Again, the AC pump has been designed with AC in mind, or maybe with the borehole yield in mind. So the maximum flow rate of your AC pump was probably the design basis for the pipes. That may be totally different, and typically, and as I said, about 80% of cases, it will be different to the pipe requirements for your solar pump. Take our first example, where we had a much smaller pump doing the same job. Same with the tank. So you may need a bigger tank to account for the shorter operating hours of a solar pump. And if you add all that into your bill of material and your total cost, then again, the whatever it is, 3,500 or so costs for the pump get in relation more and more insignificant. Then another, and I think really important thing to keep in mind, once you sort of per default start up your compass every time a customer comes in and asks for a solar pump solution, no matter whether he or she has a pump or not, then you'll very quickly realize that there is a significant difference in terms of efficiency and use of power between a solar pump and an AC pump. So that's just one example. That's actually our Ghana pump. So this is the one we've looked at in example 2. This particular pump at 50 Hertz max speed gives us 7 cubes an hour. We do drive this pump, and you can see and can check that on your own compass design. We do drive this pump at 55 Hertz, which is probably sounding very strange and maybe even dangerous to you if you're coming from an AC pump background, because AC pumps, as I mentioned before, are designed for a fixed speed 50 Hertz operation. And to my knowledge, there's only LORENTZ that offer higher speeds, because it's only LORENTZ, to my knowledge, that sell pumps and controllers made and designed from the same people, made in the same factory, and shipped as a solution. Others typically mix and match pumps and electronics. So that 5 Hertz difference in this particular configuration gives us the difference between 7 and 12 cubes, or 60% more water. Mind you, same motor power, same PV generator, same location, same sun, same everything. Just the better matching of controller and pump and the higher max speed gives you 60% more peak water. If you remember the price differential between, I think it was $13,500 and $19,000 for the solarization versus the new pump application, then actually this increase in flow rate matches very well the increase in price. So you're actually not selling liter per or dollar per liter a more expensive solution. You're selling a better performing solution. Now you may say that's all good and nice, but my customer may not be able to spend the $19,000. He may only be just able to spend the 13. Great. Then sell him a solar pump solution for 13, which means sell him the right pump for the job. So exactly the pump we've chosen, our PSK25 12-15, but don't sell him all the PV at the beginning, the 10,450 watt, but sell him, say, 6,000 watt, which would be then basically the same price as the solarization exercise. Yeah, maybe let me go back to that overview to make that more obvious. So we are back here, right? So Let's assume we take away from our 10.5 kilowatt, we take away 4.5 kilowatt, and to make it 6 kilowatt. We would then drop some 4 or 4,500 from this bill, and you're really relatively close to your 1,300, 450. And you're not even compromising on flow rate, because you know this pump gives you 60% flow rate more than another pump can, simply because this is a higher speed operation. So I hope that's a compelling argument for solarizing an existing installation rather than solarizing an existing pump. Yeah? Our job is not to keep the old pump in. Our job is to make sure the customer gets the flow rate he needs and gets a solution in the budget that makes sense for him or her. In the end, it also boils down to an extent on your appetite for risk. And when I say your, I mean both you as the reseller and both you as the end customer. So obviously, if you buy a new solution from a reputable manufacturer, you have a performance guarantee. So if Compass says you will get that amount of flow rate, you will get that amount of flow rate, and you have pump scanner to check it. So whether or not the Frankenstein solution will do what it says, that's very difficult to say, honestly, because no one even knows how that particular pump would work with this rule of thumb sizing PV generator in this particular situation. Honestly, no one knows. So you don't get a performance guarantee on this solution. Look at after sales service warranty. Honestly now, who is responsible if one thing or one part works or not? So let's take the more realistic or the more frequent case. Your pump just gives up, and we'll look at why it's very likely that your pump will give up. Your pump gives up, so you've not installed the pump as the solar inverter installer. Who's now sitting with the problem? Well, the customer will call you. You will say, sorry, I didn't install that pump. The customer will then probably call the pump installer. He will say, go away, that pump is out of warranty, and I did not sell you that inverter and PV, so please go away. This is, I told you from the beginning, solar is not working. So what happens is the customer is standing in between. In whichever shoes you are, you have a bad situation because you have an unhappy customer, which is bad marketing, right? At least, and it's a very bad situation for you to be in, and of course also for your customer to be in. It's also bad for solar pumping, really, if you're honest. So if you're earning your money with solar pumping and you have a large number of unhappy customers, whether or not you sold that or someone else, it's bad for all of us because it gives solar pumping as a solution a bad image. And of course, you will have mismatching. Your inverter does not know your pump, so you will not have a good communication between the two. You'll be losing out on a lot of flow rate. So the question really is, how much do you actually save? Is it significant? Yes or no? And are there not more and smarter ways to sell your customer an actual solution while adhering within his budget limits? Obviously, there is more to pumps and controllers than just the cost or the water production. So the LORENTZ solutions, they all come with inbuilt applications, which allows you to make very good use of sensors. Take your motor meter, for example, which gives you the ability to simply tell the pump me 50 cubes a day, and it will. Take your pump scanner, which gives you immediate access to the inner workings of the pumps, to the operations of your pumps. Take the fact that our systems are designed for off-grid, which means, for example, that they don't derate under high temperatures up to 50-degree ambient. Or take the fact that you can replace components on board level if something fails. So there's a lot more to solar pumping than just moving water. There's inbuilt applications and aspects around it that makes it just that more performant than your off-the-shelf inverter could.
Kai, can I just,
Obviously,
sorry, jump in for a second? Your slides are
sure.
frozen from at slide 14. If you could just maybe update the slides.
Ah, okay. How do I update the slides? It says, hang on, maybe this, give me a shot whether this works
That's
now. Can you
working.
see
We're
the
on the
hybrid?
we're on the hybrid slide now. Maybe you can go back one just to get those
Yep,
points again.
sorry. Um, this one I think you did not see then.
We're still on the hybrid one there. I think maybe going back slides is not working too well, so maybe you just need to go to.
Could be. I've rechecked now the sharing. Is it now showing?
Yep, we can see 16 now.
That's systems designed for solar water pumping. Sensors?
That's all fine. Yes.
Okay, great. So that's what I just talked about. Sorry for that. By the way, that's Adrian. So this is the slide I was talking about when I said it's designed for solar water pumping. It has the better high temperature performance. It has the inbuilt features for protecting the pump and the motor. It has sun sensor, and obviously it pumps a lot more water as well. So I just try and not go back to other slides. So hybrid is another unique point that you have with a true solar pump like the LORENTZ. You can blend power sources. So you can, and by blending I really mean you can mix at any point of time power from AC, so from grid or from diesel, with power from the sun. That's opposed to switching, right? So hybrid pumping is not switching between AC and DC, but hybrid pumping is blending a power source to achieve a target. So if your target is a constant flow rate or a constant speed, then the only way to achieve this is by using and applying hybrid power and not dual power. Obviously, our solutions can also do dual power, and they can do that automatically, switching between diesel and AC, maybe during daytime and nighttime hours. It's all logical and a simple operation. So in summary, saving money can be a very expensive exercise, like we saw on case one, where it sounds obvious, but actually, if you look at it, it's not, simply because the operational hours between AC pumps and solar pumps are not correlated at all. So it may be just a slim chance that they do match. And in case they do match, then look at how much money you do actually save. Typically, it's 20–30% at best. And even those 20–30%, if you're really short on cash, can be saved by simply designing a smaller PV generator on the, anyways, more performant LORENTZ pump to get your customer to afford the pump. I think that the third learning should be use your compass, not your thumb, right? In the 80s, I think it was still okay to use your thumb for that, but we have these software tools and they're great and they're much faster in calculating than we are. So why not use it? And I really recommend use it every time. And lastly, we are all living from solar water pumping. So let's make it work. Let's make us create happy customers and not just sell another inverter or another kilowatt of PV. So that's now a good chance to answer some questions. We had a few coming in. Let me just review some. So what we have here. Yes, we have a good question here from David, who's asking why do we and how can we accept higher speeds than 50 Hertz? That's a very good question. So that changing between the maximum speed of 50 Hertz that you do with any other LORENTZ or any other solar pump or any other AC pump for that matter, and 55 happens automatically, and it happens constantly. So when we design a solar pump, what we do is we look at the flow speed, the power consumption, and the efficiency. And if you find a good operational point where the flow speed is still sufficient to cool your motor, and by putting higher speeds into it, you will actually achieve more performance in terms of more water, then you can do that. But obviously, for that exercise, you have to own the pump, you have to be the maker of the pump, and you have to know your pump's performance under all operating conditions, from literally whatever it is, starting maybe at 20 hertz to 55, 60 hertz. Only then can you make that decision. And if you go through Compass, you'll find that many, or actually every pump system has a different max speed. So this particular one has 55. There's also others with 56 or 51 or 52 or 53. So you find that we don't do this blindly, but we really do this based on a deep knowledge on how our pumps operate and which pump can be used at this higher speed and which not, and how high that speed may be. I hope that answers the question. We have another question. Oh yeah, question here. That's also a very frequent one. Is, can a LORENTZ controller be used to run regular AC pumps? Yeah, it can. And it can actually in a very elegant way. Not that I would necessarily recommend it, but it does work. And I think the trick here, or the thing that is really important to keep in mind, is that our controllers behave a lot nicer towards a pump than any other controller does. And when I say nicer, I mean our controllers make sure that that pump or that motor in particular is running in an operational mode where it cannot either have too many start-stops or is overheating because of insufficient flow rate and insufficient cooling. And to achieve that, we have shipped with every of our controllers bigger than 1800 a sun sensor. So that's a little PV module, I think some 5-6 watts, which you install alongside your regular PV generator. And what it does, it measures the irradiation, and corresponding to your Compass report and to your pump scanner setting, it would only allow the pump to start whenever there is sufficient power to not only start the motor, but actually to pump motor up. And that really reduces the lifetime of solar pumps, if you don't have it, significantly. So let me elaborate on that a little bit further. So this is how the sun sensor is increasing pump lifetime. This yellow curve here is your sunshine intensity, so the amount of energy you get from the sun. Obviously, that's biggest on midday. This blue curve here is your water production. And so it's quite obvious that when the sun rises, which may be on the equator at around 5:30 or 6 o'clock in the morning, then the pump doesn't immediately start, particularly not an AC pump. And the reason is that you need a certain minimum power to get that motor going. And particularly in part load, AC motors are not particularly efficient. So the controller starts really early in the morning, because the controller is like a computer. It has very little power consumption. So power from the PV, and if it's just a couple of watts, is at sunrise already big enough to start it. And it does its job, which is trying to start the pump. So you have probably about 2 hours in the morning, 2 hours in the afternoon, where your pump tries to start, or your controller tries to start your pump, but it fails. And if you have that every minute, for example, as some controllers do, then you have, even on a perfect solar day, some 240 failed start attempts within a window of maybe 12 hours. So please check your motor manufacturer's warranty statement. I'm rather convinced they will not warrant that sort of operation. So typical is, even on the really very high quality motors, typical is you have about 200 start stops in a 24-hour period. And now we are talking at 12 hours maximum. So it is definitely your pump will be out of warranty by the time you put an inverter on it. I think that's already by this time, that's a fact. And again, we're not talking about LORENTZ now, right? We're talking about solarizing an existing pump. Then you have about an hour in the morning and an hour in the afternoon, this red bar here, where you have enough power to start finally the pump, but insufficient speed to get the water up to the surface. That's Bernoulli principle. You need a minimum speed for a centrifugal pump to actually create enough lift to achieve water being pumped up. So what happens there is that you are moving your motor, you are moving water inside the well and inside the pump, but you're not pumping it up. So the motor is not cooled by the water sucked past it by the pump head. Insufficient cooling, you may be aware, is never covered by warranty, and it's a very, very direct route to death for any motor, right? Any motor needs cooling. If you don't have that, it'll die. And that's just not happening occasionally, but that's happening regularly, unless you know at which point you have sufficient power to actually pump the water up. And the only way to test this is really to start the pump, which is not good because we don't want failed start attempts. So, and the only way to really get it right is to measure the irradiation, because this point here, where this yellow curve hits the black bar, the red bar, this is when you finally have enough power to not only start the motor, but actually to lift water up. And that is why the sun sensor is the only means to make sure that your AC drive in solar mode is living as long as your AC drive would live in AC mode. So diesel driven or grid power driven. Let's look at further questions. Oh yeah, we had a question here on whether we will share the presentation. Yes, we will do. So it's going to be shared to everyone who attended after the webinar. Now is a good chance for you to ask any other questions that you may have, because we are just about to wrap up the main content here. I had here a question on motors. Why is the motor cable in my sizing 50 meters? Well, that's just because we had to come up with a motor size. That's not something particularly relevant for the case of solarizing a pump. Okay, here's another good one by Duncan. Duncan is asking, can you further explain the difference between LORENTZ AC motors and other AC motors? Yes, I can. There is no significant difference between good quality, so say Grundfos or Franklin motors, and LORENTZ motors for AC. We use standard high quality AC motors for our job. The difference is in the combination of motor, pump end, and controller. We're the only manufacturer who brings out these as a solution from a factory, from the same design team. So we can do things like smart sizing, we can do things like increased speed, we can do things like sun sensor. Okay, Azanath is making a comment that she thinks that Compass is a very nice tool for solarization because you can benchmark between what a sort of full blood, pure blood solar pump solution would do and an AC solar pump solarization pump would do. Okay, good. So I think that's basically almost all the questions answered. To sum it up, what it is for you really, it's to make an informed decision, right? So is your existing pump the right size? If it's too big, it's going to be inefficient, right? You're spending too much money, like in our example number 1. If it is too small, then it simply does not meet the requirements of your customer. Secondly, is the existing pump suitable for solarizing? So how about the age? Is it already 3, 4, 5 years old? Then certainly it does not make any commercial sense to leave it in. Is it designed for variable speed? If not, then you'll damage your pump within probably weeks or a few months. And how about protection? Will you have to pull your pump anyways to install a dry run protection? And thirdly, how about your appetite for risk? So what are you gaining, right? You don't have really a performance guarantee whatsoever. You actually don't know how much water is being pumped in your solarization exercise. Your savings are at least debatable, right? Even in those 20% of cases where you can theoretically leave your pumping, they're at least debatable. And you definitely will have future costs, which normally will exceed the cost that you have if you do a clean solar water pump installation in the first place. So that's the end of this presentation. I would like to thank everyone very much for joining. So as we mentioned before, this has been recorded and we will share this recording with you so that you can rewatch it and also share it with your colleagues. I would be, and we would be as LORENTZ, be very happy to get feedback from you on the content of this presentation, but also on content that you would like to see in future webinars. Anything that you think could be adding value to your day-to-day operations is more than welcome, and we will try and account for that in our upcoming presentations. So thank you very much once again, everyone. This was a brilliant occasion, I think, opportunity for us to get in touch. Stay safe, everyone. Wash your hands, and I hope to talk to all of you very soon. Bye-bye.